We are excited to have Katie Bell presenting What Even Is Code? Building a Non-Code Coding Interface. So just a little bit about Katie. She has more than 10 years experience as a professional developer, working across companies such as Google, Grok Learning and Campaign Monitor. She's also volunteered in education to help rookie coders get started, which I really appreciate. Today, she's going to talk about her quest to build a coding interface with no bracket matching, no syntax errors, and no whitespace, and share her exploration of what code even is and how human language influences how we think about it. Just a reminder that Katie will be taking questions at the end of this presentation, so post your questions in the Venulous chat and we'll get to them at the end. Over to you, Katie.
Awesome, thanks. All right, so what are we going to talk about? We're going to talk about what even is code. And so here is some code. This is some simple JavaScript code. And the thing about the way that we do code is that it hasn't really changed very much since the 70s when, C was developed. It was influenced by languages before that, but the syntax hasn't changed that much, and the way that we code fundamentally hasn't changed that much in that time. And regardless of whether you're using a Notepad or Vim or Emacs or some kind of sophisticated IDE, fundamentally, we're still writing code by entering the same sets of punctuation characters, words, and symbols into a text file that is then stored as a text file and handed over to like a parser, interpreter, or compiler. And why do we do it this way? Why have we been doing it this way since the 70s? And it's largely because we're used to it. Even if someone develops a new programming language, they typically just keep using the same structures and syntax that people are already familiar with, because then it's easier for developers to pick up. And when you, like me, have been coding for a long time, it starts to feel really natural, and you don't necessarily realize what you have done and how much you have learned to get to that point, because writing code in a text file actually forces you to remember a lot of things. And when you're starting out and you don't already know those things, it has a really difficult learning curve, because there is so much stuff that isn't necessarily intuitive and you just have to remember it. So starting with punctuation symbols. We use these throughout our code, and we typically use punctuation and these symbols in a way that is not intuitive if the only thing you've ever done before, which is what most people have done, is English or whatever language you've learned plus mathematics. In coding, we use these symbols in entirely new and unexpected ways, and you just have to learn what they mean. You have to learn what they mean in order to read code, and especially if you want to write code. And these symbols, we have a limited number of symbols available to us on the keyboard that are easy to type. And so we tend to overload those symbols and use them for multiple purposes in any particular language. So as an example, in JavaScript, you can use curly braces to define a new object. You also use curly braces to define a block of code for a function or an if statement. You also use curly braces to destruct an object or to insert a variable into a template string. And again, multiple uses of the same symbols in different contexts. It's not ambiguous, but you do have to learn each one of these different uses to be able to read code. On top of that, even once you've learned the syntax to a language, you might find that there are extra hidden things that you only encounter sometimes that, again, you just have to learn or look up on Stack Overflow over and over again. You might already know that in JavaScript, a string is delineated with quote marks, but then one day you'd find you have to write a quote mark inside the string, or a new line, or a slash, and you have to learn the escaping rules for that. HTML is particularly annoying for this because the escaping rules mean typing ampersand GT semicolon in order to type a greater than symbol, just so that it doesn't accidentally get interpreted as part of the code. On top of that, you also need to learn operator precedence rules to be able to understand what the code is going to do. And some rules are things like multiplication comes before an addition operation, and that's fine. People learn that in school. People learn that in primary school. They later learn that again in high school. It kind of gets drilled into you. It's not that weird for people to pick up basic operator principles, like a basic operator precedence. But in code, we take that to another step and add many more operators than the ones that you would use in high school. And you start to find that you have an or operator and an and operator, and a beginner coder isn't going to know that an and operator takes precedence over an or operator, so that bit gets evaluated first. If you've done university level maths, maybe you know this, but most people haven't. And so this is something you just have to learn. And this even goes so far as to say that, like, I've seen style guides in companies where if you have more than one and an or, you have to add the brackets just so it's clear, and so that people aren't expected to remember as they're reading the code which one of these goes first. Even if you're an experienced programmer, you might find cases where the operator precedence and associativity rules surprise you and behave in ways that you don't expect. So this is the power of or exponentiation operator in JavaScript. And you could kind of interpret this phrase in two ways. Either it's 8 to the power of 2, or it's 2 to the power of 9. And unless you happen to know or remember that JavaScript exponentiation operators are right associative, you wouldn't know or even necessarily be able to reasonably guess that the second one is actually the way that this is interpreted in JavaScript. And so these things are kind of mostly okay. You have to learn them for a particular language, but there's only a limited set of rules within a language that you have to learn. You only have to learn it once, and then you can remember it and code many more things over and over again. But it's not just the language rules that are things that you have to keep in your head as you're coding. And in particular, if you read this code, this is getting a canvas, HTML canvas element, and it is drawing to that canvas element, and it's drawing an arc. And this arc function has 5 parameters, and just by reading this code, I can't tell what this arc function is doing, because I don't know which parameter is which. I can probably guess that the first 2 parameters are an X and Y coordinate, but the rest of the parameters, I'm not sure what they are. The code has this information, but because we don't want the code to be redundantly copying the information over and over again, because if you change it in one place, you'd have to change it in another place, most languages don't have the parameter names embedded in a function call. Some IDEs do this. Typically, the IDEs that are aimed at professional developers, high-end IDEs that cost money are the ones that do this, and the beginner-level IDEs typically don't have this information, and you just kind of have to learn it. But now that I have these parameter names, I can see that the third parameter is the radius. Okay, there's the radius of my arc. The start angle is 0, and the end angle is 2 pi. Oh, now I can understand that this is drawing a full circle, now that I understand what these parameter names actually are. And there's a lot of information that you have to remember and keep in your head if you want to be able to code without stopping to go look up stuff on Stack Overflow or in the documentation every single step of the way. So when you start coding and you're presented with just a blank text editor, like, how are you supposed to know what to write? There's so much information that you have to learn before you can competently write code. You have to know these arbitrary symbols and the multiple meanings that they have. You have to know the syntax of the language, the keywords and the rules around it. You need to know the operator precedence rules and associativity rules to a certain extent before you can really make use of those. You have to remember the functions and variables that are available to you in whatever library you're using, including those function parameter names and the types of any variables that you use or create yourself. You have to store that information in your head. And there's a lot of cognitive load associated with writing code, which makes interruptions particularly damaging for developers. And makes coding particularly difficult to start learning as a newbie, because it takes time to start to remember all of these things as you're coding. So what else is there? We've been mostly coding in text files for decades, but that's not the only kind of code that exists out there. And there are a number of really interesting visual coding interfaces that have found solutions to these problems. There are ways that you can write code where you don't have to remember and formulate in your head everything that you want to write. So my favorite example of this is Scratch. And Scratch is particularly well known. It's a very popular language. It's very popular among children, teenagers, and beginner coders. And the thing that's beautiful about Scratch is that you don't need to actually remember anything. You have this tray of blocks available to you, and you can just look through the list of blocks and you find a block that says very clearly, turn to the right 15 degrees. And you can understand immediately what that block does. And even if you don't know what it is that you're looking for, you can still find blocks and start compiling a program out of them. And so there's no kind of weird symbols that you need to remember. And the blocks are available to you whenever you need them. You don't have to remember what the blocks are or how the blocks are worded when you want to write some code. This makes it very easy to just open Scratch and start writing something. On the downside, once you do become familiar with Scratch and once you do start to build bigger and bigger Scratch programs, and people have made amazing, complicated games in Scratch, once you know what you're doing, there is no faster way to get those blocks. You still have to open the tray, find the blocks that you're looking for, and drag it into the program. You can't kind of just type a few keystrokes and magic the block into existence if you already know what it is that you're looking for. So it does become a bit cumbersome and difficult to work with once you start building bigger, more complicated code. My other favorite example is the Unreal Engine blueprints system, which is this kind of also sort of block-based where you have these blocks that represent function calls and conditionals. And again, you don't need to remember things in order to code using the blueprints engine. You don't need to remember that the launch character function has these parameters over here on the right. You don't need to remember that the launch velocity is a vector. This yellow symbol means that it's a vector. Also, you can see that it has an X, Y, and Z coordinate here. You don't need to remember that this is a Boolean. There's a checkbox here, and the red symbol indicates to you that it's a Boolean. So the variables available to you, and even when you want to create a new block, there is just a list of blocks for you to choose from. You don't need to remember anything. And this is why in Unreal Engine, even people who are very familiar with coding and are very competent professional coders, they will still use blueprints for parts of their system because it is easier to write and faster to write than actually writing the code for it. Again, there are some downsides. It does take up a lot of screen space for a smaller amount of code. And for a larger, more complicated program, you end up with lines going everywhere unless you're very careful about how you structure the layout of the code. So there are some downsides to this. And also with both of these examples, with Scratch and with blueprints, these coding environments are limited to a sort of specific domain problem. There are specific kinds of programs you can write, and you can't necessarily do everything that you could do with a regular text-based programming language. And I've gone looking through many different visual coding interfaces, and none of them really do what I want to get out of a coding interface. Like, I don't want to have to deal with syntax and symbols and parse errors and matching brackets and whitespace and indenting. Like, I don't want to have to deal with these things. And in particular, I want to be able to teach students how to do web development without having to teach them 3 different kinds of syntax in order to make anything happen. When you do web development, you really do need to know HTML and CSS and JavaScript. And that is a lot of syntax and a lot of symbols and a lot of contradictory things that you need to learn in order to be able to do any of that. So what I want is something that will let me code in JavaScript and not restrict me into one specific branch of problems. I want to be able to do anything that I can do with JavaScript, but without having to deal with text files. And this is not an easy problem. And this is how I started on this kind of epic quest to climb a mountain and find out if such a thing is even possible. And so here I am on my quest. I'm still very much at the beginning of this quest, but I will hopefully show you that I am already at least making some steps and learning some things along the way to solving this problem. So let's be a little bit more specific about what it is that I want. So firstly, I want a real world programming language. And in particular, I want to use JavaScript because I want to be able to build UIs and do web development. So I want to have a complete and functional implementation of JavaScript such that I'm not locked into some environment where if I want to learn real coding, I have to get out of that environment. I want it to have a layout that is readable and scannable, and I don't want it to be sort of spaghetti blocks all over the screen where it's kind of, you have to follow lines and to trace through what is going on. I don't want it to have these arbitrary symbols. I don't want to have to type the symbols, and I don't want to have to understand and learn what these weird symbols mean to be able to interpret it. Everything should be either words or structures that are very easy to understand. I don't want to have to deal with operator precedence rules, and I don't want to have to learn those operator precedence rules. And I don't want it to be a drag and drop interface. I want to be able to navigate the code quickly. I want to be able to add new elements to the code quickly in a way that I can probably just, if I know what I'm doing, I should be able to just type it and make it happen. I want it to be as fast to edit as text-based coding is. And yes, I guess I'm asking a lot here. This is not an easy thing to achieve for any of these things, but I'm willing to spend a lot of time on it. So let's see how we go. It did not start off very well. So let's start with experiment number 1. And I called this the AST builder. So what is an AST? This is an AST. So for a very simple line of JavaScript code, which is console.log, where we're logging the value x plus 10, the first thing that happens when you take text-based code and process it to run it is it gets parsed into what's called an abstract syntax tree, or AST. And in this case, the AST would look something like this. There is a call expression, a function call expression, which is the top level node, and it has 2 children. It has a call-e, which in this case is a member expression, console.log. And it has a set of arguments. And in this case, there's only one argument, which is a binary expression, which has the operator plus. And so that is our expression that indicates x plus 10. And these things combined is the way that the computer understands code. And what I want to do is skip the middleman. I don't want to have a text-based representation of the code. I want to have a tree-based representation of the code so that I can directly manipulate this abstract syntax tree without having to type characters and symbols that provide the structure to this tree. So when you have code that looks like a tree, instead of adding sort of characters to a string of characters like you would in text-based coding, you have these operations that you can perform on the tree, like an insert operation where you add a new node to the tree. And this might mean you're adding a new argument to a function call. It might mean you're adding a new statement to a block of code. It's that kind of insert operation. Or you might delete a node from the tree. You might delete an argument. You might delete a line of code. You might delete a whole if statement. It's removing something from the tree. But a lot of the time in code, what we actually want to do is what I would call a wrap operation, where you're inserting a node partway into the tree between 2 existing nodes. And this might be if you have a string and you want to pass that string into a function, you would wrap that string in a function call. Or if you have a plus b and you want to make it plus c as well, that is a wrap operation on the binary operator. So I wanted to be able to do each of these 3 kinds of operations on a tree representation of the code, but I want the code to be readable in the way that code is readable. So this is what I built at first. It's very basic. It only ever handled a small subset of JavaScript. It was never actually runnable as JavaScript, but I had the idea that you could kind of see it like code, but when you click on something, it shows you the options that you can do with it. You could insert statements before or after, or if you click on a particular variable, you could wrap that variable or insert things before and after it. So you could say, wrap this variable in an operator that then gives you options for what to fill in on the other side of that operator. And honestly, this UI was kind of terrible. And the buttons popping up and disappearing all the time was a difficult user experience. And honestly, nothing in this prototype actually worked. So I learned from this that UI design is hard. I've been coding for a long time, but I'm very much a back-end and sort of DevOps engineer. And JS syntax is quite complicated. In order to have a tree structure that represents JavaScript code, there are a lot of different kinds of nodes in that abstract syntax tree. If I was doing Lisp, this would probably be much easier, but JavaScript has a lot of different bits of syntax associated with it. So I decided to make this problem a bit easier for myself. And instead of focusing on JavaScript to start with, I decided to focus on HTML and build an HTML editor that again had the same properties, that it was a tree-based structure that you would insert and delete and wrap nodes in the tree. So this HTML editor has a lot of the same properties as JavaScript because it's still a tree structure. It's just a simpler kind of tree. In HTML, there aren't that many different kinds of nodes in the tree. You basically have elements, text nodes, and attributes on those elements. But it does have some similar properties to a JavaScript or otherwise code tree, because one node in this tree can have multiple sets of children that are distinct. A div element has a set of attributes and a set of content to it, which might be other elements or a text node. Just like in JavaScript, an if statement would have multiple children in that an if statement has a condition to it. It also has a body, which is the code that happens if the if statement is true. And then it might also have another child, which is an else or an else if statement. So having a tree, which is a simpler tree, but still has some of the properties of like multiple different sets of children and how to navigate that, was a good test of whether this kind of tree-based editor idea could even work. Okay, so it's going to load the video. And this is what I built first as experiment number 2. So this is an HTML editor. You can see it has sort of HTML head, body elements. You can select any one of these elements. You can hide the editor, and you can see that what I'm editing here is a fairly standard HTML sort of template page with some filler content in it. But you can select a text node, you can edit that text node, and it updates the frame HTML live. In the same way, you can kind of delete a node. There's this kind of purple cursor that you can move around with the keyboard. You can select a node, edit a node. And in this case, we're editing an attribute on one of the elements. In the same way, I can select a node and perform a wrap operation by hitting that little wrap button at the top. The UX for it is a bit janky, but I've now wrapped this h3 element in a div tag. And let's go to the next slide. Okay, so ultimately this actually kind of works. And one of the nice things about this is because it's stored in a tree structure, escaping anything that's in the text so that it doesn't accidentally get interpreted as a tag is just a non-issue. You can write whatever characters you want into this text string, and it will only ever be interpreted as a text string. The operation to add an element is a separate operation. So escaping disappears as a problem in HTML in this interface. And when we're editing this interface, we can do all 3 of these operations. We can do inserts, we can do deletes, and we can do wrap operations. And it's not the greatest UI because I'm a terrible UI designer, but it showed me enough that this solution was workable. What we can do is navigate with the keyboard. We avoid escaping. The design is not great. I'm not a fan of these kind of like boxes of rounded corners. It takes up a lot of space. It makes the code hard to scan. It was clear to me that the tags were kind of difficult to see and the attributes were particularly difficult to see because there was no UI around them to indicate where one attribute had started and another one finished. So if you look over here, there's like a space here, but there's no quotes around this attribute. It's very hard to tell sort of that this is actually one class attribute on this span tag here. So a couple of issues, but it was enough to give me the confidence to have attempt number 2 at tackling JavaScript in the UI. So if we go into JavaScript, I learned that I needed to build design mocks before I started coding anything so that I at least had something that I was working towards. Again, I'm not a UI designer. Even my mocks were really not that great. But it gave me something to kind of think about, how do I represent these JavaScript structures with things that are very clear that there are two sets of children associated with most nodes. And I came up with some ideas, and then I started implementing again. And as placeholders, I did use some characters to symbolize the sort of start and end of a set of brackets, and I used brackets for this. You don't actually type the brackets in this UI, but they sort of were there until I could replace them to make it look more like the mock later on. So this was the interface. It looks like code, but when you select a node, it highlights the whole node. So this if else is one node, this sort of declaration of variable is one node, and the declare and as come together as a unit. You don't have to type them individually. And you could kind of add code. You could add arguments to this console.log call here, and some parts of the interface were working and some parts of the interface were not working. In particular, you could do insert. It was reasonably easy to code up insert in a tree-based system because you just kind of find a place you can put a cursor. You put the cursor there, you insert a new node. It's not that bad. Deleting nodes was also reasonably easy to implement, but wrapping a node was incredibly difficult to figure out how the user interface would work for a wrap. You could select a node, you could try and hit a wrap operation, but that wrap operation doesn't work in JavaScript anywhere near as well as it works in HTML. In HTML, if you're selecting an element and you wrap it, the only thing that you can wrap it in is another element. And it's very obvious where the original element should go. It goes in the content of the new element. So it's not that complicated to implement wrap. But in JavaScript, it is difficult to implement wrap. Because as an example, let's take this plus operator, and it has two children. So this is x plus 3 in tree form. And let's say I select this node and I want to wrap this node in another bit of an expression. And I want to wrap it in a minus operation. So I select this node, in some way I hit the W key or I click wrap. But do I mean that the minus sign should go on the left such that my original addition is to the right of that minus? So it's something minus x plus 3? Or do I want it to go on the right so that it's x plus 3 minus something? And there's no way to know this. And so you'd need to get the user to indicate whether they want to wrap left or wrap right. And this honestly just wasn't working. There was no good way to represent this because if you're learning to write code, you don't want to have to learn what a left and right wrap operation is. And so I decided that the solution to this was to make the tree structure more visible in the way that you write code, so that when you do add a wrap operation, it would be much more visible what that wrap operation is actually doing. And in fact, all of the tree structures would be more visible. It'd be much more obvious that you're working on a tree and not working on just a series of text-based characters. So I started experimenting with some mocks for different kinds of tree structures to see how they would work. I started to move forward a bit more with this one. You can see in this if statement here that there's like an equality operator. So this is basically x is equal to 100 as our if statement. And whenever you make a design mock before you're implementing anything, you should show it to people and say, hey, like, do you understand this? What does it mean to you? And I showed this to people and they're like, I don't understand what's going on with that equality thing. And so I decided to make it a little bit simpler and keep that kind of idea of there's a left and a right child by structuring it a bit more like this. So in this top example, you have a plus 100, and it's much easier to figure out what's going on. And this looked fine until I implemented it and realized that when you have multiple things in the structure, it then becomes very difficult to read again. And I showed it to people, and they're like, I don't get what's going on with this thing. And you can kind of figure it out, but only when people would put everything in order would they be able to understand it. So this structure only makes sense once you interpret it and go, okay, 8 plus 2 is equal to 100. Oh, okay, now I understand what that means. So I decided that things needed to be actually laid out left to right. And I came up with this form where the tree structure is still reasonably clear, but you can read it very easily. Okay, yep, I'm declaring a new variable b, it is a plus 100. Cool. But again, when you start to build a more complicated expression, it then again becomes difficult to read. And I showed this example to people, and one person was like, I get it now because I can read it left to right, but I don't like that in order to read this line, my eye has to track sideways and then loop down and come back up again. And I showed this to another person and they're like, I don't understand. Why does the plus come first? What does that mean? And I realized that they were following the line rather than reading it left to right. And so this structure was still very unclear and non-intuitive to interpret. And I ended up having to give up one of my principles, and I allowed operator precedence to exist. So for most of the code structure, I still want it to be a tree. It still works quite well as a tree structure. But for operator expressions and for sort of expressions of this form, it is a series of tokens that you can just add a token to the list and then it gets parsed when you need to parse it. And this works so much better. Like this is how languages fundamentally work, and this is how people have been doing maths since they were a child. In a language, in English or other sort of similarly structured languages, when you have a preposition, you say the cat is in, or the cat's in the tree. And that is how we think. We think in words, and that is how mathematics is structured as well, because that's why you put the operator in between A and B. So it's A plus B, and you can read that and think about that in the same way that you think about an English sentence. And making things into some kind of tree form doesn't actually make them clearer for this particular kind of thing. So I had to give up on my goal of not having operator precedence, but the operator precedence is limited to just these standard left and right side binary operators and unary operators, rather than being a series of tokens is how the entire code is interpreted, which is what text code is. So the rest of the code is still fundamentally tree structured. Function arguments are still sort of represented as this tree list. Our if statement still has a child, which is represented in a tree-like way, and a series of statements in the body, which is also represented in this kind of nested indenting tree structure. But the expressions themselves, I have caved and gone in with more of a token approach. It's still a little bit easier than text code because the tokens are already tokenized for you, and it's not just a series of characters, it is a series of tokens. But it is a little bit more in that halfway ground between a full tree structure and a text-like code structure. Okay, so this one started to work better. It started to become easier to edit. It started to become easier to develop more features and make it more usable. So I developed it further. And this is what I have right now. So this is a video. And although I started off building, again, a JavaScript interface with this tree structure, once I had a working system, I was able to add in HTML as well, such that you can create HTML and then add a script tag. So here we have an HTML document, it has a head and a body. In that body, I can create an image element. I can give it attributes. In this case, I'm adding a picture of a kitten. I create a heading tag. I can then put some text content in that heading. And again, because this is a string node, it does not have any concept of escaping in it. So you could put quote marks or anything that you want to inside that string and it will just work. Now that I've built a script tag here, inside the script tag, the interface knows that this is where JavaScript goes and not a place where it should be auto-completing other HTML elements. So I can start writing actual JavaScript code here. And it's got some autocomplete. So I've got document.getElementById. I'll add an ID back on that heading tag so that I can get that ID here. And on the next line, I can then take that heading element object and I can manipulate it. So I'm writing fairly standard pure JavaScript code here. And it's taking that text content and it's replacing the text content of that heading tag. Now the auto refresh isn't fully implemented yet, so I do need to skip forward a little bit to where it's refreshed. So I go up to the top, I sort of go to another page and come back. And when it reloads, that JavaScript is being executed and the contents of that heading tag has been changed. So this is a fairly simple example, but it does work. It doesn't work in every way that I want this system to work. You still have to remember to a certain extent the tags and functions and variables that you want to use, because there is autocomplete, but again, it's only as good as autocomplete can be. You have to kind of start typing what you want before it would really autocomplete in a useful way. I still have the dot operator for member expressions, and you still have to remember the variable and function parameter types, even though the labels are there for something. So what it does have autocomplete for most built-in JavaScript things. And even though there is a dot operator here for a member expression, it's kind of represented in a way that helps you understand what's going on. It has this kind of little arrow bit here, which is like the breadcrumbs that you might see on a website, which show you that this thing is like, this is where you are in the navigation tree of the website. So it's a little bit like that. There's autocomplete. There is also automatically labeled function parameters for built-in JavaScript types as well. I find with set timeout in JavaScript, I always forget that the timeout value goes second, and when these are automatically labeled for you, it's much easier to figure out which parameter goes where. So those labels are there, you don't have to type them, and they're sort of shown in the UI in a fairly unobtrusive way. So yeah, it's at the point where you can build something that is not necessarily a real world project. I haven't implemented all of the JavaScript syntax yet, but you can build enough of a website that it might actually do something. So in this example, we've got quite a bit of JavaScript code here. I'm not expecting you to read all of it. There are sort of 3 separate functions, including setting like an onload handler. And this sets up an HTML canvas element, which has a ball that bounces around. Like, it's very exciting. But you can build actual JavaScript code in this system now. And when you're building JavaScript code using this system, you don't need to remember these arbitrary symbols and punctuations, braces, and HTML tags. You just need to, the only things that you need to learn are the actual semantic meanings of what the things are. You don't need to have escaping rules either for HTML or for JavaScript, which makes it easier to sort of seamlessly move between the two. I did cave, and there is still some operator precedence, but I have made things like and or into structured tree elements rather than tokens. So you can limit how much operator precedence actually affects the things that you have to learn. You also don't need to remember function parameter names, although that only works for built-in functions right now. I do not infer them for functions that you create yourself. So this is what I've got so far. I've called it Sploot Code. You can find it on GitHub. If you want to have progress updates, there is a website with splootcode.io. You can sign up to like a mailing list and get updates on it. I'm still very much at the beginning of this journey. There is a lot more to go before I have a complete implementation of JavaScript and before the system is usable. There's a lot more to go in terms of making it easier to get started and to find the programming tools available to you if you don't already know what to write. So that blank page problem is still a problem. I'm still working on that. But it's at a point where I think there's promise here. I think there's, it's starting to get to the point where you can write code and you're typing fewer characters than you would have to type. You're hitting fewer keystrokes than you would have to type to code in JavaScript. And you can still build complicated bits of JavaScript code. So it's making progress. I'm excited about where it's going, and I'm going to be continuing to work on this. If you would like to join me, that would be amazing. I particularly need help with UI design. If you know anyone that's interested in working on a very difficult UI design challenge. Anyway, that is all I have to explain. I do have time for questions, which is great. And I will be around in the chat afterwards as well, and I'm fairly easy to contact either online or on Twitter. So, yeah.
Thank you so much, Katie. That was amazing. I certainly learnt a lot, and the visuals are really great. And I don't know if you need help with user interface, because you seem to be all over it, checking in with people, seeing if they can see how it works, the tree structures. So that's great. There's been a lot of lively chatter on the Venulous chat, but we do have some questions for you. So first up, how does the HTML editor handle adding text tags like AM bolding tags inside the text nodes?
That is a really great question. The answer is it doesn't. That is another UI challenge that I have not solved yet. There are ways to do this. So with several of even the open source text editor windows out there, you can have text editors in an interface which let you add sort of widgets inside the text in the flow of the text. So it is solvable from a UI perspective, but that's a great question because it's very clear, like from the interface that I've got so far, that doesn't work at all. And if you wanted to put, say, a bold tag inside some text, you would have to create separate text nodes. You'd have like a text node, then a bold node with the text in it, and then another text node afterwards. And having them spaced vertically in the UI is not a great UI for that, but anything that you can write in HTML, you can actually write in this interface still. It's just, there is a much easier way to do it, which I have not implemented yet. So okay. Great question.
Okay, so up next, how does the HTML editor handle, oh sorry, we've got that one already, will there be a plugin architecture to do all the languages?
This is something that I learned very well from going through multiple prototypes. In the early prototypes, I had to write a lot of custom code and a lot of repetitive code to add new language features to it. And in the fourth prototype, I got rid of that and I started writing a kind of generic system for adding a node to the language. So in the code, if you want to add a node to the language, you create a kind of subclass of the node object. You set a bunch of parameters and you set essentially maybe this much code to define how that node should be laid out in the UI and what children are allowed to be added to that node. And so it's kind of this plugin architecture where you can add a node to the language relatively easily. One of the advantages is in the future is that people could potentially define their own custom nodes, and adapting the UI to a new language would actually be pretty straightforward, which is why when I had gotten a working JavaScript implementation, it was actually very easy to add HTML nodes as well, because this node architecture was actually quite pluggable. Yeah. So yes, eventually maybe there will be a plugin architecture to do all the languages, but I would like to get at least one working first. Yeah.
Okay, so next question. Any thoughts on referencing other variables, function pointers other than just by name?
Yeah, this is really great. This is one of the things that I think is a real advantage that you could have to a structured node tree-based language. Instead of having just a text string for a variable name, it could be just a straight up internal reference to a variable. The tricky thing about that is you have to be very careful how that variable is represented to the user, because named variables are a very convenient way to show to the user what variable this is. At the moment in my interface, a variable reference is just a string reference. It's exactly the same as an identifier in the abstract syntax tree. I do want to change this. I do want to implement exactly what it is that you're talking about there, which is when you define a variable, anything that references that variable is a direct reference to this. I haven't implemented it yet because it gets a little complicated when you're dealing with things like shadowed variables from another scope. When I show you a variable name in the UI, I need to make it clear to the user somehow whether this is a variable in the local scope or a variable in a global scope that is the same name. And in text code, this is confusing a lot of the time, but because the variable is just a string name, it's a runtime problem, whether or not it's the local scope or the global scope. In a system where that variable reference is a direct reference to a variable, it's confusing because it's probably referencing whichever variable was the variable of that name in the local scope or in the global scope when you wrote the code, regardless of the changes that happen to that code afterwards. So it is an interesting problem. How do you represent that that variable is of a particular scope, even if someone might have created a new variable in a different scope of the same name?
Wow.
So but it gets hard, but yes, absolutely, I want to do that. Yes.
That's great. Okay, so we'll leave it there. Thank you so much for presenting. That was amazing. And I think you said also that you're happy to take questions in Venulus after the presentation and in the post-talk Q&A channel. So we're going to take a lunch break now. We're back here at 1:30. And presenting next at the Rusty RH Hall is John Manning with his talk on let's use an automated theorem prover to verify video games. And he swears that this is more fun than it sounds. So we look forward to that. Thanks again, Katie.
Cool. Thank you. Bye.
Bye.